Good morning and or good afternoon and perhaps even good evening once again. Today's date should be Wednesday the 29th of April. Well, it is Wednesday the 29th of April, but you may not be doing this lesson on Wednesday the 29th of April. But the plan is that we do two lessons a week, one which will come out on a Monday and the other will come out on a Wednesday. But if you've decided to do both on Monday or some other day as per suiting your time, then that's absolutely fine. So lesson 2. Formation of the solar system. That's what we're looking at, how the solar system formed. And once again, we have a challenge: identify non-planetary features in the solar system. And in Aspire, describe the formation of a solar system. So last lesson, we spoke about the planets. Now you might think, well, hold on, it's a bit of a strange way of doing it logically. Surely we should have spoken about the formation of the solar system and then spoken about what's in it. Yeah, I did think about that, but I thought actually with the formation of the solar system, what you've got is you've got some non-planetary features, which we're going to go through, that are actually remnants of the original formation of the solar system. Now, the likelihood is, but again, you may know them, but the likelihood is that you don't know much about these features, not as much as you knew about the planets. So I think the planets was a good one to come into, and now we're going to look at some other features within the solar system that might be able to be described or explain perhaps how the solar system originally was formed. So my name, as you should know by now, is Mr. Kamwar, Associate Director of Science, and let's crack on. Let's see what we've got today. But before we start, what we always need is paper and pen. Now, I know I didn't make it absolutely clear in the last lesson, but you know, if you've got an exercise book or if you've got an A4 pad that you want to work through, you're very welcome to have a section that's science, and you can keep all your notes there. We're not in the business of forcing you to take notes at various points. I'm not going to stop the PowerPoint and say this is the time for you to take notes. You are very welcome to pause the PowerPoint, or at the end of every PowerPoint there will be some summary notes that you can get down if you wish to for your own understanding. Now do remember that obviously at the end of every lesson you will be given tasks to complete, so it might very well be useful to have the notes, but if you are using your mobile phone and you can't do this, then that's absolutely fine. If you're at home with a laptop or a computer or an iPad or a tablet or something like that and you're able to do so, brilliant. But I do fully appreciate that not everyone will have the facility to watch and to write at the same time, and that's absolutely fine. As long as we are learning, that is brilliant. So today's starter, quick recap of the previous lesson, what I'd like you to do, and you'll have 30 seconds to do so, but you will probably start now. Write down the order of planets in the solar system, and if possible you can write down an additional fact about each one. Okay, fire away. Right then, 30 seconds up. Obviously you can pause it if you've not managed to do that. So really quickly, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. If you put Pluto down, that's wrong. If you've got any other order, that is obviously also wrong. Now obviously the additional fact about each one you could get from the video from the previous one, or I'm not going to go through every single fact that you could possibly have, but do have a look and see whether those facts are correct. Right. Hopefully that was a quick recap of the previous lesson. Right, let's crack on with the next. So, what are we going to be talking about today? We are going to be talking about non-planetary features in our solar system. So we're not talking about planets today. You can see the keywords below: heliosphere, Kuiper belt, Kuiper belt, depends on how you wish to say it, but Kuiper belt is how you should. Asteroid, Oort cloud, O-O-R-T, Oort cloud, and a nebula. And what we are looking at is as follows. So what you can see is the solar system. So we've got the sun, and you can see the sun just over here. You can see me with a very dodgy looking circle, but anyway, there's the sun. We have ourselves, beautifully placed there. So there is Earth in the outward purple, of course. So you can see the distance between the Sun and the Earth. It is as so. You can see the distance there. And as you continue, you get to Mars. And the first thing that we'll be talking about, so pointing out Earth, very good. I didn't realise I had such good animation skills. So there we go, there we got Earth. And we're going to be talking about the asteroid belt. So that's the first non-planetary feature in our solar system that we're going to be talking about. The asteroid belt. Now you might have an idea about it. Most people do know that it's between Mars and Jupiter. And perhaps people know a little bit about what it may contain, clumps of rock. But we will talk about it in a little bit more detail. Another area that we're going to talk about is something called the Kuiper belt. So you can see that it's beyond Pluto and Neptune. So we've got Pluto and Neptune here that I'm just circling. So there's Neptune, there's Pluto. And if you remember last time, we spoke about the vast distances that we're talking about. So Neptune is really far out, but Kuiper belt is even further. And you can see that it's just around this part here. So it's at the edge of something called the heliosphere, which is the third area that we're going to look at, the heliosphere. Now, helio is from the sun, sphere is obviously a 3D shape. So it's basically this area, which I'm drawing in blue currently. This area here is all the heliosphere. Where is it coming from? Well, it's coming from the sun, of which we will go and talk about in a bit more detail. So we've got the asteroid belt, we've got the Kuiper belt, we've got the heliosphere. And you'd think that'd be the edge of it. And then we get to interstellar space. And the final bit that we're going to look at is something called the Oort cloud. So the Oort cloud is beyond our heliosphere, which I'll talk about later, and it's way beyond those borders, twice as far essentially, and it's this area in between our solar system, so our solar system that I'll put in a big circle, and the next star, which is Alpha Centauri. So it's kind of halfway between it. So it's kind of like the last border that we've got. And those are the four features that we're going to talk about. The asteroid belt, the Kuiper belt, the heliosphere, and the Oort cloud. So we come to our first feature, which is the asteroid belt. It's the closest feature that is to Earth. So the location is between Mars and Jupiter. So that's where it is. What is it? Well, basically the asteroid belt are bits and pieces of rock that are just simply left over from the formation of the solar system. So what you've got is clumps of rock. You've got clumps of rock that basically didn't form a planet, or that an asteroid could have hit an early planet and it's separated from it, and then you've got the remnants of it. There's various theories as to how they've all come about, but the asteroids are quite interesting. Very few of them are large enough to hold their own atmospheres. However, in between some of those, in the asteroid belt, you do get some dwarf planets, very similar to Pluto. And there are two dwarf planets that I've got here for you. One called Ceres, which is just here, and the other one called Vesta. So they're two dwarf planets within the asteroid belt. Now, why are they classified as planets? Basically because they're a bit bigger and they're spherical. Well, I should say more spherical than others. So what happens is you get clumps of rock and ice, and due to gravity, they kind of stick together, and that stickability that they have, because they create a larger or greater mass, so more particles get drawn to it and they clump together, and eventually what you create is a spherical object if there is enough of them and the gravitational force is great. So Ceres is a good example of a dwarf planet that's formed. Now, some other asteroids are just simply piles of rubble that are really just held together by gravity, and basically they're just clumps and they're not even connected. So you couldn't you couldn't walk across one to the other. That's just how they are. Interestingly, and Donald Trump has actually started to talk about it, but many people think that there's a lot of minerals and metals, particularly iron and nickel metals, on these asteroids, and perhaps in the future there could be some mining that could occur within the asteroid field, that basically, because we're running out of resources on planet Earth, that we could therefore send probes to some of these asteroids which aren't that far away. I mean, still quite far away, but they're not that far away, and we could send them and we could mine those and bring those minerals and resources back. Because they are not supposedly that far away. And obviously there are theories to suggest that many early asteroids and comets that eventually hit may have brought water and ice to it. And that's where we eventually got quite a few of our minerals and water from. Okay, so that is the asteroid belt. So after the asteroid belt, we go through the planets. So we move through Jupiter, Saturn, Uranus and Neptune, and beyond Neptune, of which Pluto is one, you get to an area called the Kuiper belt. Now the Kuiper belt was named after Gerard Kuiper, who was a Dutch-American astronomer. However, nothing was actually seen in the Kuiper belt apart from Pluto and its moon Charon. It wasn't seen. Now, sorry, correction. Some people call it Charon, however, others call it Charon. And again, it's named after the Greeks. So just be careful with that. It's not just Sharon from EastEnders or anything. It could be Pluto and Charon. So anyway, what was I talking about? Albion, which is also curiously, Albion is a prehistoric name given to Great Britain. Many moons ago, but Albion was first discovered in 1992 as part of this Kuiper belt. So before then we didn't even think that it existed. It is beyond the orbit of Neptune, so it's just further beyond the orbit of Neptune. Now what is it? It's basically the same as the asteroid belt. It just contains small bodies or remnants from when the solar system first formed. However, most of these asteroids are made from rock or metal. But there are some, what we call, in the astronomer field, what we call volatiles, basically they're ices. So for example, you will find materials such as methane, ammonia and water all frozen as some kind of ice asteroid type object. So that's what you'll find. So it's not just rock and dust that you'll find, but you'll also find these frozen volatiles, and perhaps these are the remnants of where, say for example, water, methane and ammonia first came to Earth. So maybe these are the parts of the planets that didn't form, okay, when the solar system was formed. Now in the Kuiper belt, which is, as it says, 20 times larger than the asteroid belt, there are 3 major dwarf planets, of which one used to be a proper so-called planet, Pluto. Here we are. Now, this is an interesting one. How would you like to say it? Make? No, make. Depends on how you wish to say it. I'm not going to tell you off for it, but make or make is another dwarf planet, and Haumea is the third. You can tell, now this is an interesting one, considering what I said earlier. Which one out of Pluto, Makemake and Haumea would you regard as the smallest? Well, if you came up with the idea that Haumea was, you're quite correct. It is the least spherical object, therefore it has the least mass, and so it's just held by gravity rather than it necessarily being as massive, so to say, as Pluto or Make. So the theory goes that the greater the mass that comes together, that pulls together because of gravity, the more spherical that object may be. However, many of these dwarf planets have been absolutely bombarded with other smaller asteroids or comets or other materials that have been flying about. And because of those, the shape and maybe the orientation of those asteroids aren't how they should be. But there you go. That is the Kuiper belt, the location beyond the orbit of Neptune. We then move to the heliosphere. Now, the heliosphere isn't an object as such. It's not an object. It's not a concept either. It is like it's like a massive field that exists. So you can't see it. You can kind of say there's a border to it, but it is basically a constant flow of charged particles that is called the solar wind, and it extends out and forms a cavity. And the cavity formed is within interstellar space. This bubble within the heliosphere is continuously inflated by plasma originating from the sun. Now that sounds really complicated. However, the key thing for us to understand at this stage is it forms a giant bubble around the sun and the planets, and that shields us from interstellar radiation. Okay, so that's where it comes from. So the heliosphere was the idea, the concept came from a gent called Alexander Dessler. He first came up with this idea, and then there's a whole area of physics called heliophysics, which includes space weather and space climate. Quite interesting stuff. And you can see from some of the diagrams. Now this one's an interesting one. This one here. Because it looks like the sun, which is here, is like a comet. It's like it's flying. Not sure why I'm drawing the arrows, but anyway, it looks like it's flying in that direction, doesn't it? Well, do you know what it is? Quite simply, it is. And when we will go on to another lesson when we talk about galaxies, and the sun is moving. Now, the sun's not moving around the planets or anything. The sun is orbiting the centre as such. It is flying around the centre of the Milky Way galaxy. So as much as the planets, so get this in your mind, the planets orbit the sun, so the sun orbits the centre of the Milky Way galaxy. So they're all moving. Now what that diagram shows, so what this diagram shows up here, is that it's moving in that direction, therefore creating a huge tail behind it. And in front, it's got like a protective area. So in front, it's protecting us from all this interstellar space radiation that's here. And as it flies through, and it's obviously flying through at quite a speed, so it protects us. And you can see that a bit clearer on that diagram. So here you've got interstellar wind, not as we know it, but interstellar wind. And then this heliosphere around here, I should really change colour, shouldn't I? There we go. Well, quite like this, you know. So this area here is protected because it's got this giant bubble, so all our planets are protected. That's basically what the heliosphere does. Okay. So we move to our final non-planetary feature, and it's called the Oort cloud. Now, I'd be kidding you if I'm some sort of expert on this. I have to admit, I find the Oort cloud quite conceptually difficult because it's theoretically we think it's there, but we don't necessarily have the evidence, definitely not the photographical evidence that it being there. It's mainly a theory that the Oort cloud defines the so-called cosmographical boundary of the solar system. So what do I mean? I mean in cosmic space, that's the absolute boundary of the solar system. So this is beyond the heliosphere. So you know we've got the heliosphere that we spoke about. This is beyond it, and in this area, in this Oort cloud, which is so far away, actually what we're talking about is up to 3 light years away. Light year. Now, I could go into it, but we are going to talk about light years in another lesson, so keep that in mind. So 3 light years away, quite quickly, it just means light takes. So you know, like I said earlier in in a previous video, that it takes 8 minutes for light to get from the sun to the Earth. Well, essentially, any light from this point of where the Oort cloud is would take 3 years to get to us. So that's how far away it is. Now that's a very simplified way of thinking about it. However, we will go into in much detail. Going back to the Oort cloud, it is that far away. And what's in it? Well, actually, we just think that it's made up full of icy comet-like objects. Okay, some of these are absolutely massive, some of them are quite small. Most of our comets, we believe, come from the Oort cloud. So as the solar system and the sun moves around the Milky Way, so it comes into contact with various other materials in space. Some of those will have gravitational pulls. So passing stars and the Milky Way itself will have a gravitational pull on various objects within the Oort cloud, and that will distort them and send them into the heliosphere and the inner atmosphere. So we think some of the comets come from there and have a great big orbit from outside into the Oort cloud and into the heliosphere and then in around our sun. So the Oort cloud is definitely a theory rather than we've seen it, because we haven't seen it. It was first proposed in the 1930s and onwards into the 50s. So, but we only think we know that that it may have been caused by when the first gaseous planets, i.e. Jupiter and Saturn, were formed, that they pushed some of the material back out. As they moved closer to the sun, they pushed some of the material back out of the heliosphere. So that's what we think we know about the Oort cloud. Quite an interesting aspect, to be honest, but something we don't know much about. But I'd encourage you, absolutely, I'm going to encourage you to have a look and see what you can find about the Oort cloud. So what are we going to do now? Well, quick learning check actually. So quick, you're going to write down 1 to 5 on your sheet of paper, or if you've got something else, you can, I was going to say if you've got a whiteboard, but you're not going to have a whiteboard. So if whatever you have got, if you can just put 1 to 5, there are 5 questions coming up, more multiple choice. Let's start with question 1. Where does the dwarf planet Ceres reside? A. Kuiper belt, B. Oort cloud, C. Heliosphere, or D. Asteroid belt? Next question. Which feature is the furthest away from the Earth? Is it A. the Kuiper belt, B. the Oort cloud, C. the Heliosphere, or D. the Asteroid belt? Question 3. I will just say, I know I'm going through these questions quite quickly, but there's nothing stopping from you pausing whilst you have a think about each question. Which feature is merely theoretical at the moment? A. Kuiper belt, B. Oort cloud, C. Heliosphere, D. Asteroid belt? Question 4. Which feature protects the planets from interstellar radiation? A. Kuiper belt, B. Oort cloud, C. Heliosphere, or D. Asteroid belt? Question 5. Which feature contains the dwarf planet Pluto? A. Kuiper belt, B. Oort cloud, C. Heliosphere, and D. Asteroid belt? So there you've got your 5 questions. If you missed one of those because I went through too quickly, that's absolutely fine. Just go back in the video and just have a look at those. But the next slide or the next click will be the answers. So are we ready? Let's have a look and see what we've got. So question number 1, where does the dwarf planet Ceres reside? It resides in the asteroid belt. The answer is D. Question 2, which feature is furthest away from the Earth? It is B, the Oort cloud. Question 3, which feature is merely theoretical at the moment? It is also B, the Oort cloud. Question 4, which feature protects the planets from interstellar radiation? It is C, the heliosphere. And question 5, the final one, which feature contains the dwarf planet Pluto? It is A, the Kuiper belt. Okay, so hopefully you managed to get 5 out of 5. If you haven't, have a read through, have a look through your notes, or go to the start of this video and then just basically zoom to the section that you need to go to. So hopefully we've learned some new terms anyway, or some new features I should say, of the solar system. So next we're going to move on to the formation of the solar system. So I've decided that I'm going to give my voice a break, as much as I love to hear the sound of it. No, I don't, but even so, I found someone else who can do it with animation. and it's just better, to be honest, better than anything that I can do. So I will relent, and you can have a watch of the following video. It's only a couple of minutes long, and it will describe the formation of the solar system, but actually show you what they think, or how they think it was originally formed. Remember, it's a theory. It is not an exact science. We don't know. We don't necessarily have the exact evidence to prove that. But anyway, do have a watch.
Our solar system, the place we call home, lies about 26,000 light-years from the center of our galaxy. Our solar system, the place we call home, lies about 26,000 light-years from the center of our galaxy, the Milky Way, or around 2/3 the way up.
And since we don't have that much time,
The story of how these huge planets came to be orbiting an average yellow star is 6 billion years long. And since we don't have that much time, I'll speed it up a bit.
long ago, an ancient star
It starts
exploded,
with a bang.
littering space with swirling clouds of the materials it had made while it lived, and the heavier metals
Long
it
ago,
created
an
as it died.
ancient star
It is not the Big
exploded,
Bang.
littering space with swirling clouds of the materials it had made while it lived, and the heavier metals it created as it died.
Nebulae. And they are
We
very
know this because we can see similar
Every
fields of
nebula
dust
is
out in
different.
space
And in
today.
our case, the
They are
clouds
called
contained nitrogen
nebula,
and oxygen and
and they
iron
are very
and silica
beautiful.
and all the other stuff.
Every
needed to build
nebula
the
is
world
different,
like ours.
and in our case, the clouds contained
Then the
nitrogen
tireless
and
force of
oxygen
gravity
and
started to
iron
put it all
and
back
silica
together.
and all the other stuff
And the
needed to build
heavy
a world
engineering
like
that
ours.
produces planets began.
Then the tireless force of gravity started to pull it all back together. And the heavy engineering that produces planets
Vast
began.
spirals of dust began to form. And at the center of one of these, a rocky planet called Earth started to take
Vast
shape.
spirals of dust began to form.
Built of stardust
And at the center of one of these,
by
a rocky
gravity.
planet called Earth started to take shape.
Vast
Built of
100
stardust
million years.
and assembled
And it had grown
by
into
gravity.
a giant ball, sweeping up billions of tons of celestial debris.
Fast forward 100 million years, and it had grown into a giant ball, sweeping up
is where the
billions
Earth
of
came
tons
from.
of celestial debris.
And therefore how you and I began.
This is where the Earth
Obviously, we
came
weren't
from.
there.
But our planet would have remained
And
a
therefore
large,
how you and I
sterile
began.
ball of rock and metals, minerals forever, were it not for one more event, one more
But our
expression
planet would
of
have
the
remained a
forces of
large,
nature.
sterile ball of rock and metals and minerals forever, were it not for one more
93
event,
million miles away,
one more
at the
expression
heart
of the
giant
forces
nebula,
of nature.
the pressure and temperature of a ball of hydrogen gas had become so great that the
93
atoms were
million
beginning to
miles away,
fuse.
at the heart of the
A
giant
new
nebula,
star,
the
our
pressure
sun,
and temperature of
was
a
coming
ball of
to
hydrogen
life.
gas had become so great that the atoms were beginning to fuse. A new star,
Amazing.
our sun, was
As
coming
the
to
sun
life.
ignited, it gave off a huge blast of solar wind. A radioactive gust of energy.
As the sun ignited, it gave
This
off
blew
a
the
huge
remaining
blast of
dust and
solar
gas that was
wind,
left over from the nebula out to the
a
edge of the
radioactive
solar system,
gust of
which
energy.
is why everything is nice and orderly
This
today.
blew all the remaining dust and gas that was left over
I
from
think
the
that's
nebula
what's made the Kuiper
out
belt.
to the edge of the solar system,
In the outer
which is
reaches
why
of the
everything
solar
is
system,
nice
we have
and
the
orderly
huge
today.
gas planets, Jupiter, Saturn, Uranus, and Neptune.
In the outer reaches of the solar system, we have the huge gas planets, Jupiter,
Venus,
Saturn, Uranus, and
Mars,
Neptune.
and of course,
Further in are the
the
denser,
Earth.
rockier planets, Mercury,
Lucky for us, the Sun is
Venus,
865,000 miles in diameter,
Mars,
or
and
just
of
the right
course,
size to burn
the Earth.
consistently for a very long time.
Lucky for us, the Sun is
Long enough
865,000
to allow
miles
the
in
next
diameter,
development
or
to
just
take
the right
place.
size to burn consistently for a very long time. 8.
I did tell you that was going to be amazing. So there you go. Formation of the solar system. Quite interesting there. Wow. Well, after that cinematic experience, we have come to the end of our lesson. So we've been able to do two things. Our challenge, identify non-planetary features in the solar system, and aspire to describe the formation of the solar system that you just watched in a beautiful animation and film that I couldn't do any better. So we've got 3 tasks for you, just as last week. Oh, no, not last week, I should say, just as 2 days ago. So we've got task 1, answer the 10 multiple choice questions that follow this presentation. That will just test your recall. That is just based upon the content that is on here. And task 2, describe in no more than 150 words how the solar system formed. Now, I'll put this as question 11 on the Google form. Your teachers will mark this. Just make it really simple, make it really basic. If you want to use more than 150 words, you can, but I'm looking at 150 words as kind of the maximum there. So basically, you're summarising what you saw in that video and describing how the solar system was formed. And an extension task, for those who are interested, I'm going to give you a term here. What is known as a TNO in our solar system? So a TNO, it's a bit of a research task. So you can get your Google on, type in TNO, have a look. If you've got some space encyclopedias at home, do have a look in there. Might have a TNO, and I just want you to tell me what it is. And if you've got some interesting facts about it, that's brilliant. So TNO. So you've got task 1, task 2, and task 3. Remember today's date is Wednesday the 29th. You'll be given 1 week, so this quiz will close next Wednesday. Okay, so next Wednesday it will close. Your next lesson will be out, it will be galaxies, and we'll be looking at next Monday for that to come out. Okay, so let me just explain exactly where we're going. So you did a lesson before, lesson 1. You have 3 tasks on there. You've got 1 week from Monday, and then you've got this lesson, you've got 3 tasks, and you have 1 week, and that will end on Wednesday. And we'll go Monday, Wednesday, Monday, Wednesday. Now, obviously, if you watched it on Thursday or Friday, that's absolutely fine. But the time periods for the 10 questions or the Google quiz will stay the same. So you must try and finish it. Okay, so the final slide is just a summary notes. I'm not going to talk about it. If you want to look at it, you can pause it here and you can copy those notes down. But at the end of each of my PowerPoints, I'll try and keep those summary notes so you actually have some notes that you can copy down. Okay, well, have a good rest of the morning or rest of the afternoon or even evening. Hopefully it's not night. Have a good day. Keep safe. Keep yourselves well, and I will see you next week. Thank you very much.